Hello there, everyone. I want to say hi from a snowy Arkansas, which is rare to say, but we got quite a bit of snow this past week, so it's always nice to think about that. With that, for this week, we're going to pick up and still be in ArcGIS Pro, so this is our second week in this software for the class itself. With that, this week is still corresponding with the Gore and Curlin book that is through Esri. This is a supplemental video to that. I'm going to go into some tips and tricks that will be useful today, but also we'll come back to them in the future with different projects and different skill sets, especially through the geoprocessing side of things. But it's good to get used to it and kind of have a knowledge base moving forward of what's possible, and if you want to explore it, you can. So I'm going to walk you through some of the steps again. All right. So for today, a lot of it comes down to, again, map design, map elements. I've already uploaded a video on converting a legend to graphics. If you want to change it, check that out on YouTube, or it's on Blackboard if you're in the class. With that, the data for today primarily comes from the Dallas Open Data Portal. With that, I wanted to see what we could do in Dallas, especially given kind of some of the things we discussed in the videos for this week in class. It talked about inequality, access to different services such as food deserts itself. So if you think about food deserts and the lack of fresh produce and everything with that and vegetables, the USDA actually has a census tract file that has what they define as food deserts. We're not going to get into that today, but if you're interested in it, it's a spatial file, it's a shape file with information in it, so you can go ahead and just download it right away. But for today, I went ahead and I've downloaded the street files for Dallas, just as this, and I've already pre-downloaded them, so I'll show that in the folder here in a second. I also grabbed the boundary file of Dallas itself, and when I was going through the data portal, I found the grocery stores here. I didn't expect it, it just popped up when I was first clicking on it. One of the pains when I was going through the Dallas data portal, they did have census tracts, but it linked it to an outside ArcMap online, which isn't ideal when you want to just go to one place and download everything. So with that, I did go through the census and I went to the boundary files itself, and I grabbed the boundaries for census tracts across the state of Texas. You can see that here. I've already downloaded it again. And to match that, I also went through the data portal for the census, and I did 2019 ACS tract level population data. And you can see here I downloaded the age and sex across all census tracts in Texas. And it's mostly primarily I'm interested in population itself, and we'll get into that in GIS. The caveat to that is I did not know until I was halfway through recording this video that Dallas is across multiple counties. Me not being from Texas and not knowing Dallas too well, when I saw that there was a Dallas County, I assumed that county just was Dallas itself. No. Dallas is actually across multiple counties. So with that, I instead downloaded all the tract population information for the state rather than Dallas County itself. So with that, you can see where I saved them. They all download in a zip file. I extracted them all. And the only one I did change was the population one. So it comes in as CSV. I trimmed it down, cleaned it up, and changed the title of it to tract population and saved it as a workbook. Can still take it right into Arc Pro, not a big deal there. I didn't want all the population information, I just wanted a few things broken down by age and total population by neighborhood itself. So with that, something to think about, and we'll get into in Arc Pro, I now have population data by tract, and I also have a geographic boundary file for all tracts. Picking up from last week and even some of the work we did in Excel, how do I link those two data sets together? What is the unique ID, given that this is a spatial boundary file that I'm downloading here, and this is a data set and attribute table, if you think about it in that way, an Excel file. How do I link those two together? How do I take the information from my spreadsheet and attach it to link it to the boundary file itself? I'll come back to that, but think on that as we progress. Alright, so now that you know where the data came from, you can actually download it and do this on your own as well if you wanted to follow through and do the steps that I'm doing here. That's up to you. I'm not going to make you do that for this at all. I'm going to go ahead and open Arc Pro, and I've already added all the data files for it. So I have the grocery stores. You can see that they're popping up in Dallas. And if you right click on it, you can also give it a second. There we go. Zoom to layer, which zooms in to the extent of the layer itself. So give this a second, and there we go. I can turn on the boundaries so you can see the boundaries of the city itself. Zoom out a little bit because that's a different layer extent. You can see where they're located. And if I turn on the streets, obviously they're within the boundary as well. So we can see all of the Dallas specific layers. Something to think about though is we have the Dallas boundary. When I turn on census tracts, it's for all tracts across the state of Texas. So when you think about that, how do I then use my Dallas boundary file to get census tracts just for Dallas? Now there's a couple different ways, but the main part, it's a geoprocessing tool, but it's one that you're probably going to use in different capacities, and it's a simple clip. So you want to clip the larger file of all census tracts based on the boundary of Dallas. And we're going to go through that and do it and show you what it looks like. Keep in mind, if you're wanting to do a lot of feature analysis with it, you can see if when I turn on and off the layer here, it splits some of the census tracts in different sections. So it separates them. It's not the same administrative boundaries. So with that, it's fairly common to proportion out the population or other measures based on the area change. So you can see even down here, the full area of the census tract is no longer within Dallas. So you might take a percentage of the area from that's now in it, and do the same with your population and other parts depending on what type of analysis you want to get into. We're not going to do that here, but that's just one thing to think about. Now with that, and if I zoom out to Texas itself and go to zoom to layer, you can see all of these census tracts across the state of Texas. With that, you notice that there's a lot of different sizes here, and keep in mind census tracts are typically 2,500 to 8,000 population. So you can see that there's drastically different sizes. With that, you might wonder, well, I can't really see what areas of Texas this is, and I have a nice base map here that has some identifying features and cities and everything with that. Now, if you have this highlighted over here in your table of contents, and you go up to your appearance, you can change the transparency, so your ability to see through. If I just change it to 50%, you can see some of the city identifiers below it. So San Antonio, Austin, Houston, Dallas, Amarillo, Lubbock, Midland. So you can see some of these more populated areas, cities that are common that have greater populations throughout Texas. So as you zoom into some of these, you can see that there are more census tracts because there's a greater population, so you have to divide it more so. So with that, let's get back into our purpose here today, and that is working with Dallas specifically. So again, you can see here if I open the attribute table, the information we got and grabbed just for the tracks is truly that, just the identifiers. It's a boundary file. Now the census does provide geodatabases with specific social characteristics. I recommend that if you're wanting to do city-specific projects. Pretty good social, population, economic characteristics that are attached to it from the ACS, so you don't have to do all the merging yourself and the spatial or the joins. Today we're going to go in how to do joins, but if you take a look across these two data sets, there's one part that's in common that's going to allow us to take our spreadsheet here of the population that we downloaded from the census itself and attach it to our boundary file. And if you notice, it comes down to this longer GeoID. It's common across data sets, so that's what we're going to use to merge the two across. So I want to attach the population data, our spreadsheet here, to the boundary file. So to do that, I'm going to right click on our tract file. I'm going to go down to join and relate, and I want to add a join. We're not doing a spatial join, we'll do that later. We're doing a join based on characteristics or attributes of the tables itself. So in our first one, we know it began with the AFF, GeoID. In our population table itself, it was just our GeoID. The cool part in Arc Pro and ArcGIS in general, you can validate the join. So this lets you see how many match across the two data sets. So give that a few seconds. And you can see here that a one-to-one join has 5,254 records. An input table had that many, and there were a couple more tracks that we did not have information for. Not surprising since we downloaded these from two different parts, but we're going to keep 5,254. For us, it's okay because those are going to be some of the ones that don't have population data, and we'll get into that here in a second. So we can hit close. and I'm going to hit OK. Now you're wondering, well, did it work? We saw it run over here and we saw a little green check mark. But if I close out of this population table and come back just to the attribute table of our tracks itself and I scroll to the end, you can see the population information was joined to this table based on the GeoID. So I have the total population per neighborhood or census tract, population at age under 5, 5 to 9, 10 to 15, and 15 to 19. So much more of our youth juvenile population as a whole. So with that, what you should do at any point in time is once you join data to it, you need to export and resave your file to make sure it's joined together. So I'm going to go to Data. So I right-clicked on the file itself, the tract, down to Data, and I want to export the feature. And with that, it's going to generate some of this information. If you're working from a project, it's going to take it straight to a geodatabase that you've already created for it. Since I have not, I just want to save this as a layer in the project folder itself. So again, I'm going to just keep it to my census tract boundaries. And I'm going to say Texas tracts pop joined. And I'm going to hit OK. And what that's doing is it's resaving the tract file with the joined data, so you don't have to keep the join there. So at this point, if I open this attribute table, we'll have the same file. So if you look here, we have the good information, the same thing that we just joined together. So I no longer need the larger original file, so I can remove that. I can also remove the population data now because we don't need that since we've joined these together. Again, if we look at our Dallas, we can see here that we still have our Dallas part and we have our boundary. And you might notice why some of these might not have population. We have waterways and part of this, and we're not going to get too in detail of how to account for that, but just remember that it does exist. And at some points, if you see population of 0 or something to that effect, that might be why of just what's going on in that area itself. It could also be a heavy commercial area too. Now to venture somewhere new and something that we haven't done before, so we have our files here and we're showing the boundary of Dallas and we have our tracts below it, but keep in mind the tracts are still for the entire state. So if I go to zoom out, we still see it's the entire state. Not ideal for us wanting to specifically focus on Dallas itself. The cool part is if you wanted to look at Texas by itself, if we went to the symbology of it, we could update it to where it's a graduated color. And this is where we're getting into the choropleth maps that even your book for chapter 2 gets into. And we could do it statewide. We could do it based on population and have our upper and lower values. So if we change this up here, our field to total population. We want to change our natural breaks to, let's just say, quantile. And with that, we want our higher values to actually be red and our lower values to be yellow. So you can see here across that we have variation in total population across tracts throughout Texas. And when we zoom into some of our urban areas, metro areas itself, we have variation within cities, which is important to pick up. Keep in mind, if we looked at population density, some of these that have a larger population and come up red are also larger, so that's where you get into population density as well as when you do some of the control measures for a study. But with that, we're focused on Dallas, so let's zoom into Dallas here. And if we come back up to the top, and I still have the Texas tracts highlighted, but for now we're interested in the analysis tab itself along the ribbon up here. With that, it might take a second if you haven't clicked on it before for these tools to auto-generate and just pop up for you. Another one to get used to is just clicking on the toolbox itself, which brings up a ton of different options within here. We'll get to a lot of them in here, but not nearly all of them. With that, I've already downloaded another extension for the crime analysis and safety tools. I highly recommend just looking through, picking or clicking around, and they have corresponding information online to walk you through what's going on for those as well. But for us, we're truly just interested in one of the top ones up here. It's where we want to clip, and it gives you an idea of what it's going to do once you just hover over it. So it extracts input features that overlay the clip features. So we have that option. So our input feature is our track population file, so our Texas file. We want to clip it to Dallas, so we're going to put our Dallas boundary there. And with that, going to specify where I want to save it and what I want it to be named as. So it's going to be Dallas tracks with population. So I'm good to go there. If I hit save, it generates theirs. So make sure, bottom right corner, you hit run. Give that some time. You can see it's working here in the background. And there's a warning just because the files are in different shapes or coordinate systems. But for now, it's okay given what we're doing with it. So I can now, if I change the symbology for just the Dallas tract from that auto-generated over here in our table of contents. So if I come back, go to symbology, and say I just want to change it to a single color. And the transparency is still at 50%, so change this back. You can see now the only tracks that we see for the Dallas part were clipped to the boundary itself. So we zoom in, we can see that it was truly clipped, the larger file, to the boundary of Dallas. So that's how you use the clip function for that. So with that, if you want to keep the layer on here, you can just deselect it. For me, we don't need it since we're focusing specifically on Dallas. So you can right click, again hit remove. This is preference here, depending on what you want in your table of contents, but since I'm not going to be using it anymore, I'm just going to click remove. If you want to keep other files in here, by all means you can do that. Just get used to file management for that in your drawing order. Alright, so we have now our Dallas specific files, and I'm just going to go zoom to extent, zoom to layer, and there we go. So now we have our Dallas boundary, and we have our population here. And let's go over one of the symbologies that the book covers itself. And before we do that, if you just open your attribute table, when I mentioned there's going to be some that don't have populations, let's see. Each one here does have population, so even our smallest one was 19 with a total population. You can see that it's here. And our greatest population is 19,000, which are these over here. And if you keep in mind, these were part of larger tracks themselves, so this is just a sliver of what's left. So that's what I mean when you want to adjust for the clipping part. You have an area change. This is an example of how you would probably want to update that, because our land here is it's not the true value anymore. So you'd want to update that based on the change here. And we'll get into that and how you can calculate the geometry of a polygon so you can get square miles. And then if you are updating or clipping it, you can see how much has shifted. But for now, we're not going to get into that part of it. But just something to keep your mind on target for. So I'm going to clear my attribute since I selected one in here. I always want to clear it so if we do any analysis, it's going to show for everything. But let's zoom out a little bit and let's go ahead and get into our symbology part. So again, I have Dallas tracks. If you don't have symbology already open over here, and keep in mind they give you everything you've pretty much opened over time in the bottom. Go to appearance, hit symbology, and you should see this pop up over here. And with that, I'm going to go to just a graduated color again. And keep in mind, this is where we're following the textbook to some extent. Say I just want to show age under 5, so population that are under the age of 5. With that, I'm going to change this to quantile again. And here, I don't like the color scheme. I want a bit more, almost red to dark to light, something different that's a bit more identifiable. So I'm going to scroll. Oh. I thought there's usually a red to green one somewhere, but I'm not seeing it right now. Oh. Ooh, that is a gnarly color scheme. Let's not use that one. Let's stick to... No, that doesn't look too hot either. Alright, we'll still use this one, and we're just going to update the colors here real quick. So if I'm reversing it, so in the legend, I prefer the higher values at the top, and it goes in more of a descending order. With that, keep in mind you can still change the colors within each one. So if you click it, you go over to properties, you can change the actual color itself. So here, oh, why is it being, there we go. I just want to change it, say, to a green. So you can see these are less populated areas for age under 5. So keep in mind this is age specifically under 5. So this is where you can change individual colors if you're not happy with the actual color scale, the scheme that you chose. With that, it's not looking too hot, not as great as I thought it would. So you can always go back to your formatting, and for me it's pretty easy just to go to a grayscale black. To where our top ones have a greater population, the white is fewer with that. Keep in mind this is just a count, so it's not taking into account the entire population of each neighborhood. And this is where, in your example in the textbook, it uses a normalization function. So with that, we do have total population. So if we just do it based on total population, it shifts it for us. So with that, keep in mind you might have to change up your values again to where it shifts our map now based on that normalization part. So it's looking at the ratio or the percent of the actual population itself. So you see the shift here in the population of those under 5 years old, and you can see it even updates over here. So it takes the age under 5 and divides it by the total population. I also uploaded a nice PDF, I think it was through MIT, that goes through this process a bit, or it might just be through Esri, I can't remember at the moment, but it gives you a walkthrough of why this is important and what you can and can't do. But since we have two population measures, we can use the total population for our benefit here. Now we could change the top part if we want to look at, say, specifically teenagers. We kept this the same, so you do see a shift in that as well. Keep in mind when you update your symbology, it is changing your values here, so you'll probably want to reorder it to where if you want your high values on top, just right click on the upper value and hit reverse values, and that changes it for you. And you can see the changes across the field itself. Alright, now if we have that, obviously we have the drawing order on, we could always turn on our grocery stores to see where they fall on top of our more teen population. With that, there's always the opportunity, since we only have points here, if you click on the symbology for your grocery store itself and you just go to search, they have quite a few different store options. This is just a quick search, and they have one specifically for a grocery store. So I'm going to go ahead and just add that in. Keep in mind the size of it shifts quite a bit when you first bring it in. So if you go over to properties, you can change the size and even the color scheme of parts of it here. I'm just going to make it a bit smaller so it doesn't take over on top of what we're looking at. Now typically what you could do here then is do a spatial join and do a count of how many grocery stores there are to a specific tract. Keep in mind those are options that you could do, and we'll get into in the future. For the purposes of where we're at currently with Arc Pro, we're not going to get into that yet. But this is something to think about. Yes, they're two different layered files, so we have population data across the neighborhood. It'd also be cool to have the count of grocery stores per neighborhood. Right now you could visually go in and count each one and see how many there are, but that's going to take a lot of time and introduces a fair amount of human error in that. The other way is to do a spatial join where you're joining the points to your polygon file, and you can get a count option within that. So you would get a count of grocery stores or whatever else you want to join to it per neighborhood, or if you're doing something at the county level, you could do count of hospitals at the county level. So it gives you options there. Same way you could do it for the streets. So how we did the clip before, you could clip your streets to a specific neighborhood that you were interested in. So if you only wanted to look at streets in, say, more of the downtown epicenter, you could clip the streets based on a specific neighborhood itself and select those out and only concentrate on that. So you can make a subset from your larger data set. Same as we did with the census tracts. You can create a subset from the larger one. you can do that and go down in different geographic units, which is important depending on what you want to do. So again, today was just a brief introduction to a couple different parts of the symbology parts, to when you have population data, especially juvenile population, youth population, and you want to visually show that for an area. I downloaded open source data through a couple different data portals. The cool part is, and I'll get into this now, and this is past what we would usually do for week 2, but some of you might be interested, well, you have all of the populations here, why wouldn't you just add them all together and have a true juvenile? Yes, 19 is above 18 in terms of status, but let's go ahead and do that. So if you have the attribute table already open, you can go to add, so it gives you an option, you just want to add a field. If you click that, give it a second, mine's warming up, I guess you could say. And you see here, and if you're familiar with SPSS, this is almost like the variable view on the other side versus the data view. So down here, it added a field for you, and this is where you can change the name of it. So here it's going to just be, under 19. So it's 19, let's see, pop 19 and under. It doesn't like it because I had one too many characters in it. That's not surprising. But with that, we want to specify here that it asks, I'm going to hit enter. It asks for a data type. So here, if you want it to be text and a string, that's fine. For us, we want an actual number. For this, if you did a double, that's going to give you decimal places. Short's going to give you kind of your whole number. So I'm just going to change it to a short number here because it's just addition to it. And I'm going to specify that it's numeric. And this is where it gives you opportunities to change the decimal places, everything with that. For this, don't need decimal places or anything with that. But if you did notice, you have different options here of how you want to display the data in the number format that you're looking at. So we're good to go there. And now if we close out of, I'm going to hit save at the top here. So it automatically brought up the save tab up here under project, and we're in the data tab for it. Hit save. That's going to save this to this file. You can see it's locked right now because it's applying the changes. My computer's being very slow with just this one. So if I exit out of this part of the currently layered table and come back to the overarching attribute table, at the end of this now, you'll see we have a new population 1. It's currently equal to 0 for everything. With that, if we right click on this one and we want to, sorry about that, we want to calculate this field. So there's nothing in it currently, so we want to calculate it. And it's going to, oops, sorry, I forgot I was on only one screen. And with that, we want to then add a couple fields together. So we're specifying down here what we're adding together itself. So we have our table, we have our name, we can even make a new one there. But for now, we're just doing basic addition for this one. So we're going to take our age under 5 plus 5 to 9 plus 10 to 15 plus 15 to 19. Trust me, there's a lot of other options in here. Some of them you'll use consistently, some you'll probably never use. But for now, this is all we need to do because we're just doing an addition to this. I'm going to hit apply. And it's calculating that in the background for us. And you can see now we have the total population for that. Click OK. And it did the addition for us. So we're in good shape there. And now we could use the full population of 19 and under and compare that to our total population for the neighborhood as a whole. And you can update your map that way. With that, I just wanted to go over a couple different things when it came to symbology and introduce a few different techniques within it. Again, I already uploaded a video for those who are wanting to make your final maps and everything that comes down to your layout view. I gave you a demonstration on how to convert that to graphics and separate or ungroup those, and then you can change it from there to get it how you would like. This week's video was really focusing in on the symbology. If you're not familiar, I use graduated colors, often referred to as a choropleth map. We also see graduated symbols, and this could be based on your population as well. So if we just change this to, say, under 19 population, we want to just do quantiles. We can see now the population parameters for that. And they're just graduated from that. So if there's any questions, please reach out to me. If not, enjoy. Keep in mind some of the data issues that when I zoom in, I'm just looking at to see what it looks like. Obviously, there's not population for the specific water. It's using a centroid of it. So that creates some issues and headaches. And I'm just looking at the boundary files here to see that there are short little discrepancies within it. So with that, again, a quick one in the symbology side of things. So let me know if there's any questions. If not, enjoy.